This is Jacob's Algebra, Chapter 13, which is Quadratic Equations, Lesson 1, which is Polynomial Equations, and we're in Part 2. Now, in the Part 1 video, we wrote down the equation for number 5 parts G and H. That was x squared minus 2x minus 2 equals 0. And in parts G and H, you're given two different values for x, and you need to determine if those values of x will make the equation true. So we have x squared, and I replaced our x with 1 plus root 3. So you can see 1 plus root 3 squared minus 2 times 1 plus root 3 because we have minus 2x, and then minus 2 because our next thing is minus 2. Now, to multiply out 1 plus square root 3 squared, you have a couple of choices. One is that you can use the grid. Another is that you can use your binomial square formula, or you can use the FOIL method. I'm going to use the binomial square formula here. You square the first term, 1 squared is 1. You square your last term, square root of 3 squared is 3. And in the middle, you put the double of the product. 2 times 1 times square root 3 is 2 square root 3. Then I need to subtract 2 times 1 plus square root 3. So negative 2 times 1 is negative 2. Negative 2 times square root 3 is negative 2 square root 3. Be very careful that you apply this negative to both of these because this negative 2 is in front. That means it's negative 2 times the positive 1 and negative 2 times the square root of 3. Don't just apply it to the first term. It needs to be applied to both. And then at the very end, we have minus 2. So let's start by taking care of our numbers. We're going to do our like terms. So our straight up numbers, we have 1 plus 3 is 4, minus 2 is 2, minus another 2, that's 0. Okay, let's look at our square roots. We have plus 2 square root 3. We have minus 2 square root 3. That's going to be 0. So what we end up with is 0. So 1 plus the square root of 3 makes this equation true. Now let's try another one of the problems from number 5. Let's look at, for number 5, let's look at the equation x to the 4th minus 5x squared plus 4 equals 0. So again, we're going to try and make this equal 0. So we're going to try this for x equals 2. That's part K. X equals 2. So we will have 2 to the 4th, because we have x to the 4th, minus 5x squared, so minus 5 times 2 squared, and then plus 4, plus 4. Well, 2 to the 4th is 16. We're going to have minus 5 times 2 squared, which is 4. Remember that square only applies to the 2, plus 4. So this is 16 minus 20 plus 4. Well, 16 minus 20 is negative 4, and when we add 4, we get 0. That works, because we're supposed to end up with 0. That means you would answer this yes, or you would answer it true. In fact, on the previous page, which I forgot to say, since this does equal 0, like our equation is supposed to, part G would be answered yes or true. Okay, let's look at part L for number 5. This uses the same equation, but we're going to have x equal to negative 2. So this time we have negative 2 to the 4th. Minus 5 times negative 2 squared plus 4. Now be sure that this negative goes inside of your parentheses because your x is negative 2. Negative 2 to the 4th is still going to be 16. Then we have minus 5, and then negative 2 squared is still going to be a positive 4. And then we have plus 4. Well, 16 minus 20 plus 4 is going to give us 0, just like it did before. So for x equals negative 2, this is also yes or true, whichever way you want to answer it. So that was number 5, which is just like number 9 that I assigned for homework. Now let's take a look at number 6. The instructions for number 6 say, tell whether or not 0 is a solution of each of the following equations. Now on the homework problem, it says tell whether or not the number 1 is a solution of each of the following equations. So be sure and read your question carefully. The one I'm doing uses 0. The one that was assigned for homework uses 1. So for part A, you are given the equation 5x squared minus x equals 0. So we need to see if 0 is a solution for this. Well, 5 times 0 squared minus 0 actually equals 0. It works, so this is true. Or you could say yes. Part B uses the equation x to the 4th plus 3x cubed minus 2x squared plus 1 equals 0. Again, we're going to plug in 0. 0 to the 4th is 0. 3 times 0 to the 3rd is 0. Negative 2 times 0 squared is 0. And then we have plus 1. That's actually going to equal 1, so that is not true. So our answer here would be no, or you could say false. Okay, part C. We have 2x cubed minus 7x squared plus 10x equals 0. Now we're going to plug in 0 for each of the x's. 2 times 0 cubed is 0. Negative 7 times 0 times 0 squared is 0. 10 times 0 is 0. And that certainly does equal 0, so yes, this one works. Let's try part D. Part D is x to the 5th minus x to the 4th plus x cubed minus x squared plus x minus 1 equals 0. Again, we're going to plug in 0. 0 to the 5th is 0. Negative 0 to the 4th is 0. 0 to the 3rd is 0. Negative 0 squared is 0. X is 0. 0 is 0. And then we have a minus 1. So all of that equals negative 1. That is not true, so this one is no. It is not a solution for this equation. Now, part E says, how can you tell from looking at a polynomial equation in standard form whether 0 is one of its solutions? Well, let's look at the equations where 0 was a solution, which are parts A and C. Well, I notice in part A that x is a factor in everything. We could have actually factored this as x times 5x minus 1 equals 0. When we look at part B, which was not a solution, x was not a factor in everything. In fact, x was not a factor in the number 1, and 1 was our answer. In part C, we did get 0 at the end. And again, x is a factor in every term. In fact, we could factor this as x times 2x squared minus 7x plus 10. So x is a factor of every term on the left side. In part D, we have x to the 5th minus x to the 4th plus x cubed minus x squared plus x minus 1. X is not a factor in every term. In fact, when we plug in 0 for x, we end up with negative 1 for our answer, and negative 1 is our constant that we have left in the equation. So for part E, how can you tell from looking at a polynomial equation in standard form whether 0 is one of its solutions? If x is a factor of every term, then 0 will be a solution of the equation. Okay, that was number 6, which is just like number 10, except for number 10 that I assigned for homework, you have to tell whether or not 1 is a solution of the equation, not 0. So be sure you remember to use 1 for x. Okay, let's look now at number 7. Number 7 is just like number 11 that I assigned for homework. And we're going to look at a bunch of these different parts. Number 7 says solve each of the following equations for x. So I'm going to start with part B. Whoa, hold on, that was not supposed to do that. I'm going to start with part B. And part B says, again, it switched off of pen mode. Says, hold on. Okay, part B says 7 times x minus 10 is equal to, again, it's switching off of pen mode, is equal to 2x plus 25. So what we need to do first is multiply out the left side. 7x minus 70, because 7 times x is 7x. 7 times negative 10 is negative 70, is equal to 2x plus 25. Now what we're trying to do in number 7 is to solve for x. So that means I want to get all my x terms on one side. Since 7x is my bigger x term, I'm going to subtract 2x from both sides. And what I'll end up with is 5x minus 70 on the left side. And then I'm left with just 25 on the right side. Now I want to get the x term by itself, so I'm going to get all the numbers on the other side. Right now I'm subtracting 70 from 5x, so instead I'm going to add 70 to get rid of it. When I add 70 to both sides, I end up with a 5x on the left side. And 25 plus 70 is 95, and that's what I have on the right side. Now what I have here is 5 multiplied by x, but I want to know what just x is. So to undo multiplying by 5, I need to divide by 5. So I'm going to divide both sides by 5. And when I divide both sides by 5, I get x is equal to 19. Okay, let's look at another part. We're going to skip down to part D. 7D says 2 times x minus 5 is equal to 5 times x minus 2. First thing we have to do here is multiply out both sides. 2 times x is 2x. 2 times negative 5 is negative 10. 5 times x is 5x. 5 times negative 2 is negative 10. Now since we're solving for x, I want to get all my x's on one side. 5x is my bigger one, so I'm going to subtract 2x from both sides and put my x's on the right side. So on the left side, I'm going to be left with negative 10. On the right side, I will have 5x minus 2x is 3x, and then I have this minus 10. Now I want to get the x all by itself. I'm subtracting 10 from it, so to get rid of that, I will add 10 to both sides. When I do that, I end up with 0 on the left side and 3x on the right side. That's what 3x is. Instead of 3 of the x, I want to know how much 1 of the x is. So I'm going to divide both sides by 3, and I will end up with x equals 0. Now you may divide 0 by any number you want except for 0. Dividing by 0 is undefined. But you can divide 0 however much you want, so long as you aren't dividing by 0. 0 divided by any number that's not 0 is going to be 0. Anything divided by 0 is undefined. Okay, so let's jump down to part F. Number 7F. We have x squared plus 5x plus 8 is equal to x times x plus 4. So on this left side, we're just going to leave that alone, x squared plus 5x plus 8. And on the right side, I need to multiply this out. X times x is x squared, x times 4 is 4x. I want to get all my x's on one side, so I'm going to subtract x squared from both sides. And I'm going to subtract this 4x from both sides. So what that's going to do is give me a 0 on the right side. On the left side, I have x squared minus x squared is 0. I have 5x minus 4x is x, and then I still have a plus 8. I need to get the x by itself, so I'm going to subtract 8 from both sides, and I end up with x equals negative 8. So this was number 7. It's just like number 11. When you get to the problem where you have a binomial squared, you might want to multiply that out using your grid method. Just once you multiply out both sides, you need to solve for x.